Hello everyone and welcome to the lecture on application auto scaling. So this lecture will contain all these topics: automatic scaling, supported resources for application auto scaling, features of application auto scaling, key concepts, application auto scaling and AWS CloudFormation templates, scheduled actions, target tracking scaling policies and step scaling policies. So automatic scaling, which are the supported resources? Let's see. So first is AppStream 2.0 fleets, second is Aurora replicas, third is Amazon Comprehend document classification and entity recognizer endpoints, fourth is DynamoDB tables, DynamoDB global secondary indexes, Amazon Elastic Container Services ECS services, Elastic Cache for Redis clusters replication groups, Amazon EMR clusters, Amazon key spaces for Apache Cassandra tables, Lambda function provision concurrency, Amazon managed streaming for Apache Kafka MSK broker storage, Amazon Neptune clusters, SageMaker endpoint variants, SageMaker inference components, SageMaker serverless provision concurrency, Spot fleet request, and last is custom resources provided by your own application or services. So features of application auto scaling. Application auto scaling allows you to automatically scale your scalable resources according to the conditions that you have defined. So there are some policies. Target tracking scaling. So scale a resource based on a target value for a specified CloudWatch metric. Then we have step scaling, which scale a resource based on a set of scaling adjustment that vary based on the size of the alarm breach. Then third is scheduled scaling. Scale a resource one time only or on a recurring schedule. So let's see some key concepts of application auto scaling. A scaling policy tells application auto scaling to track a specific CloudWatch metric and determines the scaling action to take based on the metric's value relative to a threshold. The scaling policy defines whether to scale out or scale in when the tracked metric is higher or lower than a certain threshold value. A cooldown period between scaling activities allows the resource to stabilize before another scaling action starts. But if a larger scale out is needed based on the current metric value, the scaling policy will scale out immediately. Scheduled actions automatically scale resources at a specific date and time by modifying the minimum and maximum capacity for a scalable target. By setting the minimum capacity high or the maximum capacity low, scheduled actions can be used to scale in and scale out on a schedule, such as decreasing capacity on weekends when application is not consuming resources. Scheduled actions can also optimize the minimum and maximum values over time to adapt to situations where higher than normal traffic is expected, such as marketing campaigns or seasonal fluctuations, improving performance and reducing cost. Okay, next is application auto scaling and AWS CloudFormation. So this is basically the integration between application auto scaling and CloudFormation. So when you provision your resources through AWS CloudFormation templates, so in those templates there is also a provision, like there is also a feature to define those application auto scaling values, or to define those values inside those CloudFormation templates. So those resources which are created by CloudFormation will already have that feature, or those resources will be created with all the application auto scaling that you have specified. So this takes care of like end-to-end life cycle of resource management. Basically you have create, you have modification and delete. So all these things are taken care. So you don't have to like provision something from CloudFormation first, then later on go to the resources and add those value for application auto scaling. But not like that. You can just start from the very beginning through the CloudFormation. So so when you create a stack template for application auto scaling resources, you must provide the following. So first is a namespace for the target service. For example, something like AppStream. So for this, this is specific value within the CloudFormation template. So it's something like AWS application auto scaling scalable target. That will reference to that reference is there to obtain service namespaces. So service namespaces is basically out of 16 services, which one you want to target. So in this case, I'm saying like AppStream. So that is one of the namespaces. So there will be at least 16 namespaces like that. Second, a scalable dimension associated with the target resource. For example, let's say same example, AppStream fleet, then there's something called as desired capacity, and this value will go in AWS application auto scaling scalable target reference to obtain a scalable dimension. So every resource will have some other dimension. Dimension is something you want to target, like what you want to like within that threshold or within that range, which particular. So for example, in the AppStream, there's something called as desired capacity that you want to target for. And then a resource ID for the target resource. For example, it can be fleet / sample fleet. So this is the actual name of the resource, and this value goes into AWS application auto scaling scalable target reference, and you will inside that you will see the syntax and what are the resource IDs that you provide. And finally, a service linked role for the target resource. So this is a ARN, so it will have something like ARN colon AWS IAM and the actual role of ARN, role ARN, and you have to so this will also goes into the CloudFormation template. So this is straightforward. This service linked role you have to specify during the template creation. Okay, some scheduled action. So this is one of the example how you can schedule application auto scaling. So you just call the application auto scaling API and you put scheduled action. Same I talked about service namespace. So let's say this is AppStream. So this will be AppStream. The scalable dimension will be, let's say in the case of AppStream, it will be desired capacity. So resource type AppStream, desired capacity. And the resource ID, whatever is the resource ID, so you can take from AWS APIs console or from the CLI, and what action you want to take. So scale out means you are increasing. So scale out is increasing, scale in is decreasing. You can schedule at time and target action minimum capacity equal to 3. So some of the others one are creating a scheduled actions that occurs only once, create a scheduled action that runs on a recurring interval, create a scheduled action that runs on a recurring schedule, create a one-time scheduled action that specifies a time zone, and create a recurring scheduled action that specifies a time zone. Okay, next is target tracking scaling policies. A target tracking scaling policy in application auto scaling automatically adjusts the scale of your application based on a target metric value, maintaining optimal performance and cost efficiency without manual intervention. So let's consider an example where you have an application running on a spot fleet and you want to maintain a specific CPU utilization level, and you want the CPU utilization of the fleet to stay around 50% when the load on the application changes, providing extra capacity to handle traffic spikes without maintaining excessive idle resources. So this is one of the examples. So you have a spot fleet and you are saying it should maintain a 50% capacity. So if the load goes up, CPU goes so scaling when CPU is less than 50%. So scaling means it will reduce the number of EC2 spot instances. So if the load is very less, so you have very less traffic. So so let's say if it is 20%, 25%. So out of 10, let's say 10 EC2 instances, it will reduce, it will kill some of the gracefully terminate, and then it will automatically come to 50%, like adjust to that. But in case there's a heavy load and it is, let's say total spot fleet is crossing, let's say 80%, then it will spin up new EC2 spot instances to just maintain the target. So target track, so just think like target CPU and track target CPU around 50%, so something like that. And this is based on the CloudWatch alarms that it gets through the spot fleet monitoring. So by creating a target tracking scaling policy with a target average CPU utilization of 50%, application auto scaling will automatically scale out increased capacity when CPU utilization exceeds 50% to handle increased load. And conversely, when the CPU utilization drops below 50%, application auto scaling will scale in decreased capacity to optimize cost during periods of low utilization. Target tracking policies eliminate the need for manually defining CloudWatch alarms and scaling adjustments, as application auto scaling handles this automatically based on the target value that you have set. Next is a step scaling policy. So a step scaling policy scales your application capacity in predefined increments based on CloudWatch alarms, allowing for more granular control over scaling behavior. So this is incremental steps compared to target tracking policy, which is not based on the step or increments. You can define separate scaling policies to handle scaling out, which is to increase capacity, and scaling in, decreasing capacity, when an alarm threshold is breached, providing flexibility in managing capacity changes. With step scaling policies, you create and manage the CloudWatch alarms that invoke the scaling process. When an alarm is breached, application auto scaling initiates the scaling policy associated with that alarm. The step scaling policy scales capacity using a set of adjustments known as step adjustments. The size of adjustment varies based on the magnitude of the alarm breach, allowing for proportional responses to different levels of demand. If the breach exceeds the first threshold, application auto scaling will apply the first step adjustment. If the breach exceeds the second threshold, application auto scaling will apply the second step adjustment, and so on, enabling the policy to respond appropriately to both minor and major changes in alarm metric. The policy will continue to respond to additional alarm breaches even while a scaling activity is in progress. This means application auto scaling will evaluate all alarm breaches as they occur, ensuring continuous monitoring and responsiveness. A cooldown period is used to protect against overscaling due to multiple alarm breaches occurring in rapid succession. This helps stabilize the application's capacity and prevents unnecessary scaling actions. Like target tracking, step scaling can help automatically scale your application's capacity as traffic changes occur, ensuring optimal performance and cost efficiency without manual intervention. And that's all. Thanks for watching.